Today we're going to cover acid deposition, formerly known as acid rain. The reason we call it deposition now instead of rain is because it's more than just rain. It's snow, it's sleet, and it's even solid PMs, particulate material. Well, before we get into that, we're on page 419 in the textbook. Let's do a little review about what pH is. Remember, pH is defined as the negative log of the hydrogen ion concentration of a solution. And so you might remember that a logarithm is the exponent in a scientific notation. So when you have 10 to the minus 5, the minus 5 is the log. And then it's the negative log of the hydrogen ion concentration. So that's why something that's got 10 to the minus 5 has a pH of 5. Just to give you a little chemistry lesson. So in reality, solutions that have a lower number, that have a lower pH, actually have more hydrogen ions, because 10 to the minus 3 is 100 times more than 10 to the minus 5. Just to keep that little chemistry lesson in mind. The lower the pH, the more acidic something is, and that means the more hydrogen ions are in concentration. And the scale, as you know, goes from 0 to 14. 14 way down here. So something with a high pH is what we call basic. It has less hydrogen ions in concentration and more hydroxide ions in concentration. And 7 is considered neutral. It might interest you to know that rainwater is not 7. As a matter of fact, rainwater comes in at about 5.8 pH. It's slightly acidic. You may recognize that if you've ever had to do work on the family pool, for instance, because when you have a lot of rain like we're having right now, all of that 5.8 pH is going into your pool. It has nowhere to go. You're making the pool water slightly acidic. So that's going to have to be balanced out. You're going to have to add a base to your pool to neutralize that acidic rain. However, that's not the definition of acid rain. Acid rain's definition is a pH lower than 5.6. Write it down. Write it down. A pH of less than, let's do this, less than 5.6 is considered acid rain. Now this diagram is in your book. It's on page 419. There's a lot to learn from this diagram. Let me cover those things for you now. The first thing that you need to remember about acid deposition is it does not happen where the primary pollutants are pumped into the air. You know, right here, this city with all of its factories and all of its power plants is the primary polluter. But with acid deposition, it happens way downwind. I'm talking hundreds of miles downwind is where the acid deposition problem occurs. It doesn't occur where the pollution is added to the air. What do I want you to remember about acid deposition? I want you to remember the sulfur, because it's easy to remember sulfuric acid. Now, nitrogen oxides are also added to the air in these smokestacks, but what did I tell you I wanted you to remember nitrogen oxides for? Tailpipes. So sulfur dioxide, this is in keeping with the whole concept that I want you to remember. Sulfur pollution, smokestacks. Nitrogen pollution, tailpipes. Alright, so the SO2 gets up into the air, travels, as I said, 10, 20, 30, even hundreds of miles. And then what happens secondarily is this SO2 reacts with H2O and gives us H2SO4, sulfuric acid. that's a problem, because sulfuric acid is an acid that when it lands on the ground, whether it is in a lake, on land, even the ocean, it lowers the pH. So this sulfuric acid is formed. Now nitric acid is also formed, but like I just said, I'm trying to get you not to focus in on the nitric acid, because we're concerned with nitrogen and tailpipes, cars. Alright, so let's talk about the damage that happens from this sulfuric acid. Now this sulfuric acid's up in the atmosphere. It can rain down, as you see here. And like I said, it can even be tiny, tiny solid particulate matter that does damage. Here are the areas in the United States that suffer the most from acid deposition. I've been in a forest in upstate New York that is so damaged by acid deposition, the trees look like just giant twigs. Even in the summertime, no leaves can grow on them. It decimates a forest because time after time after time, the rain or the snow with its lower than normal pH accumulates and builds up. Remember what I told you about that Rust Belt area, right in this area here. All of the factories, all of the power plants is a big time thing. You can see the red dots are telling you the major coal burning power plants. It's gotten so bad that states have sued one another. The state of New York has sued the state of Ohio for acid deposition, for damage done to its trees. Now remember, the jet stream's the principal culprit here, right? The primary pollutant of SO2 gets up into the air, and the jet stream pushes it eastward. So remember that. Acid deposition is always going to happen to the east of the primary polluter. And that's what we see here. You can see the areas that have really, really bad pollution problems are the pinks and the yellows and the purples. And where are they? Look at them. They're all downwind from the Rust Belt. Big problem. Out west here, in the wide open spaces, not nearly as many people, not nearly as many factories, not nearly as many power plants, so not nearly the problem. Every now and then you'll see one. Down here in the desert southwest, several power plants, and so downwind from that you have some pH problems. But the big problem is Pennsylvania, New York, Rhode Island, Connecticut. These northeastern states are the ones that are really, really suffering in acid deposition. So now how can we deal with this? Well, obviously we need to take the sulfur out of the air. And the way to do that is to keep it from escaping the smokestack. Easier said than done. And we will cover techniques that we use to control pollution in a few minutes. Or I'm sorry, we're going to cover that in the next video. But there are techniques that we use to try to decrease the sulfur dioxide that comes out. Remember, sulfur dioxide is not an acid in and of itself, so nobody's pumping acids up into the air. But they are pumping the primary pollutant that reacts with water vapor in clouds and then ends up falling downwind. This is a very, very good map for you to kind of visualize and picture how pH problems are happening downwind from where all the power plants are. Lots of power plants here in Middle America, which is having an effect on the coastal Atlantic states here, including the forests of the Appalachian Mountains. Acid deposition is a problem in the world, not just here in the United States. When we think of it, we have a tendency to picture the forests and the lakes here in the United States. And a lake that is damaged by acid deposition, remember I've always told you, think of a lake like a bowl. So that lowered pH is accumulating, and the pH gets lower and lower as a result. More and more acid is added. And you can see here in Europe, same idea. Wherever there's a power plant, let's pick Great Britain here, all of their power plants and factories, and then the people downwind are the ones that suffer because of the jet stream moving from west to east. And of course China, now that it's developing and it's producing so many coal burning power plants and so many factories, it's beginning to have a problem of its own as well. So most of the major problems are in the developed world, and that should make perfect sense to you. That's where all the factories are. That's where all the electricity is. And so downwind from that is where all the acid deposition problems are. Alright, aside from the damage that's done to soil, to forests, and to lakes, acid deposition has damage to humans. For instance, respiratory diseases are a big problem in areas where there's a lot of acid deposition. People are breathing in acidified water vapor, so it irritates the lungs. There's toxic metal leaching. More on that in a minute. I have a nice diagram to show you that demonstrates how toxic metal leaching happens in soil. But the key word here is leaching, because the acidified material reacts with metals in the soil. It radicalizes the metal and makes it leach into groundwater. So people are drinking groundwater with these toxic metals in it. Decreased visibility, of course, can be a problem for people that do a lot of driving and a lot of traveling. So acid deposition has been linked to traffic deaths. Damage to structures. Limestone is particularly susceptible, and limestone is in marble, is particularly susceptible to pH changes. So the acids actually break down marble, and we see some of our ancient structures being damaged quite a bit by acid deposition. And then, of course, as far as humans are concerned, if you're a fisherman and you live in it and you depend on that fishery, you know, that lake or that ocean, to provide you your livelihood, or you're a forester, guy that cuts down trees, makes, you know, tables, furniture, whatever, and that forest is damaged, or if you're a farmer, these different places have an effect on humans. It's sad enough that it's killing the organisms and destroying the ecosystem, for instance for forests, but it's also harming humans in terms of productivity and profitability. Here's a diagram I wanted to show you. This one's in the book. A famous arch that's being eaten away slowly but surely because of acid deposition. And I know you kind of think of marble as a very one of the hardest substances. So remember, it's kind of interesting to realize that the calcium carbonate that's in marble gets quite damaged when acids are introduced. Alright, what happens to aquatic fisheries? What happens to lakes? Remember, if the lake is a bowl, then you're going to have a decline in the numbers of fish. Remember what I've told you so many times. Organisms do not tolerate changes in pH very well. And so we end up with situations like a decline in the organisms that will live there. This diagram is kind of showing you those indicator species that we've talked about before. Remember that worksheet that you did on living indicators? Well, you can see that when the pH is pretty good, close to 7, all the different organisms are present, whether it's a tiny little invertebrate like the whirlywig or the water boatman. They have such funny names, don't they? Or the mayfly, We had the mayfly in our worksheet. When you've got all the different organisms there, the pH is good. But as the pH declines, you start to have organisms that cannot tolerate those changes begin to disappear. And when you end up with a pH at around 4 or 3.5, there's no fish, only the tiniest, hardiest organisms that are basically, because of their life cycle, immune to the pH changes are the ones that are left behind. So we end up with a lake that's practically dead. The water looks crisp and clear. There's no organisms there. There's no algae growing on top. Algae can't tolerate pH changes. So it looks like a really, really clean lake, but it's not. The reason it looks clean is because no organisms can survive there. We have no fish. That's a problem. All right, so when a lake or a body of water, and I'm usually talking about lakes here because after all, rivers flow, right? So if the acid rain is dropped in one part of the river, it will flow down and it will end up in the ocean at the end of the line. There's always new water in the river, but there's not always new water with the lake. And so we end up with this buildup. When there are no fish available, when everything's dead in the lake, that's called acid shock. That's called a lake that has acid shock. What do you think the treatment is for a lake? Remember, it's a bowl. How do we raise the pH? We literally add a base. Literally add something that's got a high pH. And limestone, the kind of stuff that we use to line our baseball fields and our football fields, that white chalky substance is a base. So states will literally fly crop dusters over these lakes and drop limestone onto them, and that will help to raise the pH. Of course, they're going to have to restock that lake too because all the fish are dead. If the fish are dead, there's no reproduction happening, so they're going to have to restock that lake. And of course, you can end up, because there's a gap in the ecosystem, all sorts of organisms that aren't living in that lake anymore. You have the potential for exotic species to take advantage of that situation, species that can tolerate a little bit of a pH change, and they end up taking over in the ecosystem. So those are the problems that happen to aquatic systems. When you picture the effect of acid deposition, picture a lake. Maybe you've been on one of these lakes, not a great lake, but picture a lake, that you boat on or you have a cottage on or something like that, becoming acidified. This diagram shows you how it happens to the plants and to the soil. And there's lots of leaching that happens with acid deposition. This diagram is quite busy, but I will focus on a few key parts. First of all, as the acid rain falls down and gets down into the soil, we have lots of acidification that can occur. We have chemicals that are normally in the soil, nitrates, phosphates, good things to have in the soil, that react with the acids and release these toxic metal ions that I was mentioning to you before. So these toxic metal ions, they're now free ions, and they can react with other chemicals in the soil. Or these metal ions end up being taken up into the root system of the tree and killing the tree, doing real damage to the tree. And of course, as I mentioned before, these toxic metals that are not taken up by the plant can end up down in the groundwater, which is a problem if you get your drinking water from the aquifer. Essential microorganisms are killed, so there's less oxygen in the soil. Lots of problems are now starting to creep up. Some of these acidified soil nutrients can end up in the lake itself, or if this was on a coastline, it can end up in the ocean, just along the edge here. All right, so now the tree has taken this toxic metal up into it, and the leaves start to shrivel up and die. There's damage to the bark, either directly from the rain itself or from this leaching problem. And so we end up with the death of a tree. Damage to the crown, there's less photosynthesis happening because there's hardly any leaves left. You get the idea. And of course, now that you have a weakened or even dead tree, if you have a weakened tree, you have decomposers getting on top of that thing and starting to really break it down. One chemical that's been particularly mentioned on the AP exam is aluminum. So when you zero in on this toxic metal ions from acid deposition, I want you to remember aluminum. Aluminum toxicity, very damaging to trees because Al+ is something that trees will take up through its root system up into the tree and do real damage. It can either weaken trees or kill them completely. What do we do about it? Well, we've got to focus on prevention when it comes to acid deposition, because cleaning it up is too hard to do. Too much damage is done. I told you we will fly over a lake and add limestone, but I mean, or phosphate. Here it says phosphate in this example is another higher pH thing, and it neutralizes the acidified lakes. But short of that, we need to put our effort in prevention. And what that means is reducing what comes out of the smokestack, reducing the sulfur that comes out. So remember, what's always the best answer whenever we talk about solutions to environmental problems: use less in the first place. So simply by, let's say this is a power plant, simply by using less electricity, we can really help to solve the problem. If we use less electricity, less sulfur dioxide has to be pumped into the air in the first place. All right, the next thing we can do is we can try to reduce our usage of coal. Try to find other fuels for our power plants. Nuclear energy, even natural gas. Natural gas releases very little sulfur dioxide as compared to coal. Increased use of renewables because they have no sulfur in them. Now, I mentioned this in the chapter when we covered non-renewable energy sources. Increasingly, we are trying to use what's called low sulfur coal. It's a harder anthracite type of coal. Problem with that, of course, is it's the more expensive coal. But if you can talk to your power plant about being more environmentally conscious when it comes to the purchase of their fuel, they can burn low sulfur coal. Now, if we can't do that, we can try to remove the SO2 from what comes out of the smokestack in the first place. And the process that we use for that is coming up in the next video. Remember, it is not just sulfur dioxide, and so if you have to remember that nitrogen comes out of the smokestack too, we can try to help deal with that by decreasing what comes out of the car in the terms of nitrogen dioxide. That way, nitric acid is not formed downwind. And then the last thing we can do is we can penalize companies that put too much SO2 up into the air. And this is done. There are certain minimum standards of sulfur that's allowed to come out of the smokestacks, and we can tax companies that fail to comply with those sulfur emissions. We'll talk more about that as a pollution control issue in the next video as well. Well, I think that's about it for acid deposition. We talked about how acid deposition harms humans. We talked about how acid deposition harms lakes. And we've also talked about how it damages forests. And you can see here a forest that's got some healthy trees in it, but mostly the taller, larger trees are very, very damaged. They will never grow leaves again. These trees are essentially dead. And, you know, dead trees are no good even in the lumber business. So we see this type of forest all throughout the Northeast United States because of the sulfur emissions that happen Illinois, Indiana, Ohio, and Pennsylvania. And that's affecting Maine, Connecticut, New Hampshire, New York, Vermont, Massachusetts, those states that are way to the northeast. Alright, we're going to talk about how to control air pollution in the next video. Hope you enjoyed this one. Acid deposition. It's not just acid rain anymore.